So, hello everybody. So let's pick up on slide 25 here, and I want to talk about market efficiency. And what does market efficiency mean? And it basically refers to the fact it's tied intimately to the word information. Okay, so information related to a stock is right. Information is continual, and you saw all the information in your life that's come out the last month about the coronavirus and what it did to stock valuations. Now, that's basically called systemic, and most people believe as soon as this goes away, the stocks are going to go up, and we may be in for a great buying opportunity, okay? And this is known as market efficiency. Market efficiency means as information is constantly passed, stock prices are going to fluctuate, and they'll always move toward a new price. So as the coronavirus information came in, and that was systemic, all prices move toward a new equilibrium. Okay, so what does behavioral finance mean? And this is you could take a whole course just on behavioral finance in itself. And it's basically a growing body of research that focuses on investor behavior and its impact on investment decisions and stock prices. And people who study this are referred to as behaviorists, and they're studying people and how they react to the stock market. It's a fascinating field. Okay, so here's a basic common stock dividend valuation model. And what are they saying? They're saying that the common stock value today, the value of a common stock share today, is equal to the future value that's expected of all its dividends in the future, okay? Divided by, divided by its required return on the common stock. And of course, the biggest challenge here is they're trying to decide what is your required return. And that would be something where you say you can get comparable return on something of similar value, right? This is a very, very important equation. So you should definitely go over these equations in 7. So here's the zero growth model. So if we get past, it's really, really simple. The dividends never change. They're constant, non-growing. If we get past all this stuff here, the only thing we got to reflect upon is, see this equal right here? Here's the equation. The dividends don't change, so you take the dividend, divide it by your required return, and you get the price. This is a piece of cake, and nothing one has to really overly be concerned about with the mathematics, right? Basic equation. Right, now, there's a little, we'll talk about a little problem with these in a minute. We'll talk about a little problem with these. But anyway, if you go through this simple example here, $3 per share dividend divided by 15% required return, the stock's value should be $20, right? Pretty basic math here. Nothing too fancy there. And that's the zero growth model. Okay, so here's the constant. Now we have a new model called the constant growth dividend model. And when we get past all this, again, which you don't have to concern yourself about, but look at this final equation here from right, and it's also called the Gordon growth dividend model. Okay. So this is the Gordon growth dividend model. And this is a common name for the constant growth model after a gentleman by the name of Gordon. But anyway, you just take the one future dividend, okay, and divide it by your required return, but you got to subtract off your growth rate. G's the growth rate, okay? So you've got this second equation here. And that's really all you have to worry about. Again, it's not difficult. So I just want to make a couple points about this equation. First of all, there's a lot of fallacies and flaws in this equation. The first one is, let's say the stock like Google doesn't pay dividends. That means this would be zero. That means the stock price would be zero and you'd get stock for free. And that's not going to work. So there's a lot of other methods that are used besides dividends that are more frequently used, and that would be earnings or cash flow, okay? So the other problem is, let's look at the denominator. What happens if the required return and the growth rate are equal? Well, now the denominator becomes 0, and your price is infinite, and that's impossible, right? And the other third problem is, what happens if the growth rate is different than the required return? Then you have a negative price, and they have to pay you to take their stock. So you can clearly see there's a lot of flaws, and this is just a theoretical bunch of equations for valuing stock. So here is a bunch of here's a company that paid dividends over the years. You can see the dividends per share for different years, right? This little table here. And so basically, we assume that the historical average annual growth rate of dividends is an accurate estimate of the future constant annual dividend growth rate. To find the historical average annual growth rate of dividends, we must solve the following for G. Okay, so 219 was equal to the 214 dividend times 1 plus the growth rate to the 5th power. And we know these two values here, right? And basically, this is where we're basically trying to find the rate, right? Effectively, we're looking for the rate here. And you can clearly see here that this was the future value, this is the present value. And we take this to the 1/5 power, right, to get G. And we solve for G here, and it comes out to about 7%, okay? Now, you can use Microsoft Excel to do this, very simple, okay? You can write this equation in Excel and have Excel solve for G, right? Take this guy right here, and, you do the caret to the 1/5, all right? All right, so you can actually use, again, as I just said, a financial calculator or Excel to solve this, solve that problem. And again, you substitute that growth rate in, and you basically know that the dividend in 2019, I believe, right? Your required return is 15%, and you estimate Lamar's dividend in 2020 will equal $1.50. So here's your new dividend. Here's your growth rate that we calculated. Here's your required return, and you get the estimated value of the stock price for 2020. So again, you could use the present and future value functions to do this. All right, so that leads up to this common stock variable growth dividend model. And what I'm going to do is I'm going to skip this, okay? So you're not going to be responsible. I want to make this clear. You're not responsible for the variable growth dividend model. So I'll go skip over those slides, okay? Step 2, Step 3, Step 4. And we'll skip over the personal finance example here. Okay, so as I said, there's a lot of other models that are used to not have dividends in the numerator if you don't pay dividends. Okay, so if the stock doesn't pay dividends, there's a lot of other things you can put in there. So here's the free cash flows of the company. Now, a company could have a free cash flow, and this is defined in other chapters of your book. And okay. So free cash flow is the money available to give to the stockholders, basically after you paid all your bills, okay? And here's your weighted average cost of capital on all your investments, okay? So you would get the share of the value of the entire company by doing this, okay? So again, it's the present value of its expected free cash flows discounted at the weighted average cost of capital, okay? So this is the value of the corporation we just calculated, okay? So here's the value of the corporation we just calculated. And now this is the overall company. So what we've got to do is take out the valuation of the debt and take out the valuation of the preferred stock, as you see here, to get the valuation of the stock, okay? So this is how this would be done. So as in the previous slide, we got the valuation of the corporation, and now we have to subtract off the debt's value and the preferred stock's value, and we get the value of the common stock, okay?